Hi. Is the mic working? No. The mic working? No. Oh, good. New function. Okay, that's good. Okay. Sorry. Just now we are second class, although it's third week. Just very quickly review what we have done. And our goal today is to finish lesson 2. I mean, lesson 1, we have something left over, like this little bit. Then we will finish and hopefully we will be able to done with lesson 2. If not, then will be majority of that. So let's quickly review what we have done lesson 1. I mean, up to the point where we done with the soccer stuff, if you still remember. So what we are doing is try to getting started from the beginning of collecting data, look at the data quality before we do analysis, right? Because it's understand what data is and determine what kind of tool that you're going to use, right? Because remember, if say category data, you don't add and subtract. You didn't do multiplication, although they're numbers, you guys have to be very careful. And as IT manager, you often have a lot of data, right? And then which column to use, which also observation to pick will be very important to get a result from your exercise. Because if you don't study this class, then you are very tempted to use all the observation. You don't feel good, right? And that's some issue. And when you run some program, then actually, if you're missing data, you still pass through. Then you have to be very careful to check whether data is complete, right? And you understand if you don't, although your many columns are all the column measuring what you want to do, or you have to transform them, right? Actually, you see on the last class, we look at the soccer, the manager that is the most successful, right? But we have to filter out actually the manager that actually play a few games. Okay, we'll go to that again. But the idea that the main thing that chapter 1 is basically garbage in, garbage out, where you should be careful the data that you have collected or given to you, right? And how to clean it up. Okay. And I'm not going to go to every single detail there. If you want, you can check back the video that has recorded. I guess the main thing is to continue the exercise that the Python that we have been working on. I guess last time we just basically stopped here. Right, this is the last slide. I'm right? And one thing that I think I didn't talk about this slide, right? Or did I? Let me check if I do or not. Let's see. Let's go to the code lab if you have that already. Sign a little bit quickly. So look at the code lab, and then look again our class. Yeah, what for IT science? Okay. I think we are up to this point. right? Calculate the reading, and one of the things you see the calculation that still remember this last one, or you can go to the blackboard and look at this one again, and then you notice that the best manager happens to be the one who actually want to take on the game, which actually we don't want, right? We want to focus on the manager at least playing some number of games, and the book they choose is without reason. They said, I mean, want the game at least 18. There's no particular reason why 18. You can put any number you want, but they just put 18 there. So let me copy this. Then what we'll do is basically this is a filtering, right? So basically just from running this line will give you all the managers that actually more than 18 games, right? And then you just basically take those games and then just remember this is like the function filter, right? Because this is the way that being written, okay? And you sort them by order, then there would be the let me copy this, and then we can just run this in our code lab. Okay, I mean you have this already, so just go back here. And you copy and paste. There's some issue when you do the there's some issue when you do the copy and paste using this copy. Why does copy not there? Copy. Check. Okay. I see. Maybe I should open that using the okay. Using this one. Okay. Okay, let me just type it. And fine. So I have to start from beginning to look at because I run it again. So I just start from this combine data and then group by and then calculate the games, and then they group them together by manager, and then and join them together if you still recall this function. And now I calculate the win ratio, right? And then sort them, and let's see. If I look at it again, or maybe I set it equal to false. Put the bracket. So you can see once I run this one, then you focus on the manager that has games more than 50, but you can set any operation number like 30, 40. But you can see this is a very simple way to handle the data. It doesn't fit what we want to do, and then I do it again. Right, so this is a basic data analysis, and you will see this kind of graph, right? And you can easily plot the graph you want to. But I didn't do it, but you can easily plot this graph to demonstrate graphically who is there, right? Because we don't want this guy, this guy, this guy, right? Because these guys are not playing a lot of games. It's just caretakers. They just take care of the team for a while. Okay. So lastly is some details on extra data cleaning is one thing is need to remove duplicate, and we often appear many times. And actually, we saw that kind of like here, right? The data we have here is this data, the long version has that the first row and the third row are actually the same thing. So the first one, the fourth row, right? It's Brighton versus Man United, and it's not the same thing. It depends on whether you clean it carefully or not, then you may have issue. So make sure that you should have the right ID, the right data set. Don't make mistake. And N is very important. So look at the count, right? Make sure that you need ID. And as I said last time, is there's not entity row, and look at the say United Nations data, right? And the immunization record. If you try to look at, if you still recall our immunization data, let's see. I think it's here, immunization data. Let me check. I think this one, right? Let's check this data. And then if we just open this one, this is already cleaned up because it's a country. But if you go to their website, look at this data set, the immunization data, World Bank immunization. This data, if you look at the web, the one they give you is besides each country, they also give areas, Asia, Europe, and so on and so forth. And say the whole OECD country and those kind of grouping that are not eligible. Okay? So be careful, not just collecting the data. You look at actually the data, how they make sense, right? Say you know number of data, number of countries in the world is 200. But look at the row, you have 500. You be careful what actually they do, right? You know, again, this one missing value actually is very complicated, and in the database that usually you work on, usually you don't have this problem. But if you actually are IT manager, you always count data, then turn out a lot of missing. Okay? And usually there's a lot of technique required to handle missing data. Okay? Either you think you drop the observation, that is what you do, or you have to input and then you have to fill in some number, say machine learning model to fill in, right? And then try to figure out the guess what is going to be done there, right? So it's not that easy. And then when you run regression and then when you run things, do you want to handle that, right? So suppose the observation has everything except his age. How you do that, right? Or your data, suppose you work for the e-commerce website, right? The data you have is everything but his birthday, right? And do you want to still want to use data, right? It's everything is birthday history, but happen that one thing is wrong or whatever thing is not correct, one thing is missing, then how are you going to do it? Okay. Or happen to be there's some glitch in the programming collection, right? Then happen that day or for what reason something is missing, right? To say for example the hard disk is broken, right? Then how are we going to do about it, right? For that day, right? Or there's an internet connection error. In particular record is missing. So how do you want to do about that? Either you just forget about that day for everyone, or you have to fill in somewhere and do some interpolation there. But that would be the thing you have to be careful. Say, for example, right, in the data, depending on data set you do, right? One data set will call Man City, the other call Manchester City, maybe Man Dog City or Manchester City football club, and so on and so forth can be very complicated. Depends on the data source you're doing, especially your IT manager, right? Sometimes the data are inputted by user, and unless you have a drop-down box, then they will type something that may not actually be there, right? Especially when you say, suppose when you have the data where it's a text, this is a comment, where they like your product, right? It's not clicking like, subscribe, or those kind of things, right? It's not clicking, but they just like, it's good, it's nice. It's very good, right? And someone say +1. Then what do? Right? +1 is good or bad? I don't know, right? Or someone say 666, then what does that mean? Right? Do you say positive or negative? Right? So you have to, I don't know, have to handle those kind of issues there, but I mean, but it is beyond our class to talk about those, but that would be something that you have to figure that out. Okay, so this is the standard step. If you work enough data, there's something you would do regularly, and then you know how to do that, right? Just like there's a standard procedure, right? Basically, just clean the code, right? Remember, the first step is the clean the code have to be, you don't edit the code directly, but edit the data directly. The raw data, with the code to clean it up. Okay? The raw data is never to be touched. And then you don't understand how the data is being linked with different data table, right? And then look at what happened and put them in the tiny data tables, right? Yes, right? And then combine them and then write down carefully, right? And make sure that there's not missing. They're meaningful, there's no input error, right? And then if they're missing, they have to be handle them appropriately. And then remember, the last step is the most important, is to document every single step. If you write a software to clean it, which you will do to Python, then you should have no problem on writing, right? And you can see the code I've written, right? I try to, I mean, as much as possible, I do what I'm supposed to do, right? I just do the green one. So I hope you will do it, but as IT manager, I hope that's not easy, right? Because you write every single code, you will do it. Okay? Even though the step is very tedious or very trivial, then probably you should write that down. Okay. And here is how you organize a file. I think as IT manager, you have no problem doing that, but this is a systematic way to store it, right? You have the readme.txt to write it, and then the raw data. Remember, raw data should never be touched, right? You clean the files, you never clean it using Excel to clean. You should write a software to clean, because but as an IT manager, you shouldn't have a need for that. You do analysis, you would do either the Python file, R file to clean it. Okay? So that would not be easy. I guess when you write Python program, actually everything is start from the beginning, right? You collect the data, everything is being well documented. That shouldn't be an issue here. Okay. Or for document, I mean, just in case the code lab, probably I didn't say it explicitly, either you can do in this way, right? Or you can have a test there. You can just type something there, then it will be left there. Okay. Just make sure that you know there's a function that you can put down the text by the text. They use the standard markdown syntax. Right. For example, then you can use the sharp to signify this is the say, for example, I have a text here. I can use a sharp to signal that this is a section for football case, say. Football case, finding the most successful football manager in English football game. Something like that. Something like along that line, right? Then you will be very clear what you're doing, right? Just like that. I mean, very carefully clean. Make sure your data is make sure your file has well organized. Yes. This shouldn't be surprised to you as your IT manager. So this is how they suggest you put there, right? There's a do file, right? Analyze in there. So raw data, the clean data, the readme file. This is how you should structure it folder. It's not the only way you do it, but as long as you do it in the way that you can separate them, especially the most important, the raw and the clean file. Others are just something, of course, they have many DTA file, CSV file, or do file. It depends on which software you use, Excel. most of the time for me, I just use CSV file and then the R file or the Python file is sufficient. Sometimes if you use data, you can have two files. I guess you guys IT managers, so I don't think you need data at all, but you use R or Python. Okay. So lastly, just make sure that when you name the file, the final name to be self-evident as well. Try to make sure that it's machine readable. There's no space. There's no punctuations and capital letter. Then also human readable, with hyphen or underscore, and tag 0 before numbers, and then use standard year, month, date instead of the other way around. But of course, when you work for a company, they may have a naming convention. Just follow them. That would be the easiest. Okay. Of course, some of you may actually read the online saying that you should make your code as unreadable as possible because you worry about your boss trying to fire you, and you want to make sure that you're not replaceable. Yes or no? But what happens if your boss don't fire you? Then you have to, your life is much trouble, right? But as an IT manager, right, if you still want to employ them, you have a way to bench, rename your file in a certain way that when they fire, before they fire, you can do something. But right, so you should, when you work on your stuff, you should make sure that you can read it by yourself, right? If that would be the minimum thing you should do. I mean, if you want to do bad thing, I mean, but don't suffer the consequence, right? So at least when you work on your stuff, you should be highly careful. Okay. I hope that is okay. I mean, because there's just a minor thing that we left last time, but at the end of the day, just you can see, right? Chapter 1 basically say, topic lesson 1 say, right? You have to look at your data carefully, look at how to get data, how to clean up, right? And then make sure that your bookend environment, your data is going the right way, your program right in the right direction. I mean, something you should know how to do. Now let's quickly, oops, someone entered the rooms. I guess the main thing is the lesson 2. Okay. Our lesson 2 would be looking at, because we have the data, we want to try to look at data, okay, and then see the data actually tell us some story. Okay? And still, we are not getting new thing from data. We still look at the data and try to look carefully, summarize the data and try to get a better picture of it. Okay? So far, we still do not generate new knowledge, but rather we are looking from distill the information from the data, right? Just try to, just like you have a bunch of stuff, okay, under the ground, your archaeologists try to take out the dust and see the antique, what it is. Okay, we're not going to investigate in the literature what actually it is. Look at the picture and try to deduce which year the antique comes from. But we just look at it. Okay, this is the vase, this is a cup, this is a mug, so on and so forth. Okay, you just look at it very. Do not generate new knowledge, right? We're not using the cup to say, oh, because of this cup has a poisonous element, this guy is poison, right? So on. So we are not going to make any deduction from there. We just look at the data. Okay? That is called exploratory data analysis. It's just, you can see later we're looking at the summary statistics, right? Mean, median, mode, variance, kurtosis, skewness, this kind of things you learn in your stat class and there's nothing new there. Okay. Just remind you how to do it, and then we are going to do it using the Python, right? Then Python how to operate that. And then the next step is called correlation, which is chapter 4 is about, right? And if you still remember last class, one of the main goals of statistical analysis is to do cause and effect, right? When X cause Y, and there is a business decision, right? Because you want to see if you do this, will I get good result, right? I want to say implement a new website. Okay, is it going to attract more traffic, or is it going to retain more customer? Or if I e-commerce, I want to say if I have the way to order the products, is it going to improve? Or I have a new algorithm, right? Or a new feature of software, is it going to help? Right? And how can you make a decision like this? You must rely on data, right? You cannot just say, scratch your head, right? Look at the wall and think, oh, this work or this doesn't work, right? We are now a data IT manager, right? Whether it work or not should depend on the data tells you. You do a small scale experiment, that is how to get the data, right? And use the data, again, you can see whether these new features is going to be work or not working, right? The beta version, someone is going to test it, maybe within your company or some test group, then it tells you whether this would have work or not, right? And to establish cause and effect, right? The first step is to say whether actually they stay together. That is called correlation, right? That's the most easiest thing, right? If X cause Y, but before we say X cause Y, we say X and Y move together in the direction we want to, right? And then we will actually see whether X will cause Y, right? The reason that X and Y move together doesn't mean X cause Y, because there's something, maybe a lot of things behind. Maybe Z goes around, right? Maybe when you do the experiment, actually is during the good time, right? Or there's something happened in the background, you want to exclude it. So to have causality is very difficult to establish, but we'll do it in the 9th and 10th class. But at least at the current stage, we will try to do correlation. If correlation doesn't work, then no hope of getting any causality, right? So that would be what we do. And then indeed, I mean, probably later you agree with me later, is when we do all the regression machine learning, it's kind of correlation. But it's a very complicated correlation system. So correlation is the first step. Next week, when we come back, then we will learn some regression. That will be the way to discover how X relates to Y. So that will be the beginning of our journey on discovering how things are related. So let's start with chapter 3 and then quickly. So EDA, as the book would define, is how we describe the variable. As I said, it's generally no new knowledge. It just clean out the dust out of the antique you take off the ground. Okay. And why we want to do that first? You can check the data cleaning, whether you clean the data correctly, right? Look at data's mean, look at the variance, look at all sorts of things you want to look at, then you will see whether it's right. And then if you look at data, it gives you some strange pattern, then you can do subsequent analysis, right? You can ask a question like that, right? Because sometimes it is not the boss would have idea what to do with data, right? You may be responsible for the job of looking at the data, and then try to figure out, is there any way to improve your website, right? Maybe you're in charge, your boss say, okay, look at our data. Is there anything you can implement to improve our website? Is there anything to improve our system? Then you have to look at the data, right? In this way. Okay? And then you can ask simple questions, as we have done in the football cases, right? You just look at the data, who win the most. We did that. And based on that, we can ask additional questions, right? For example, maybe we can ask, maybe the nationality of the football coach would change the game, whether they win or not, right? Maybe they speak the same language would help, right? Maybe a Spanish coach may not be easily adapted to the English environment, so and so forth. That may be many reasons. Or it depends on how much money the club spend. I mean, there's a lot of questions you can ask. But maybe look at the data and give you some idea what kind of question to ask. So that would be the meaning of EDA. And of course, you have a lot of variables, especially the IT manager, right? So a lot of columns, right? So, but we will look at the key columns because you don't have enough time anyway, right? So we can see what kind of value they have, how often they take, and our extreme value, right? We have we do that, right? Look at the histogram, and also we will look some standard thing you learn in the undergrad, right? The mean, the variance, so on and so forth. And that would be the way to go. Okay. And of course, very important, more often than not, is you look at extreme values, especially the ID data. There may be some give in the program that makes some crazy thing, and then you have no control. Okay, and then maybe extra zero there to make sure that everything is all right. Okay, so of course, there are many plots you can do. In look at the book, they will tell you that we'll just focus on one particular type of graph. Then you will do is we look at the histogram or the density plot. That will be the one we focus on. But you can look at all sorts of graphs that you think that fit your case. But we only look at this as an illustration. Okay, just don't think this is the only way to do it. But there are many ways to do it. We just focus on one because. And we look at the frequency or histogram. There's two ways. Look at the absolute or relative. Okay, and you may ask, okay, they're very similar. But why you don't do both? Later you see when you want to compare relative is factor. Okay, and there's a little bit tricky thing is the missing value, right? When you just count number of things that's missing, there's no problem, right? Because you miss it, okay, just don't deal in the data. But when it's relative, the total, how do you count the missing value? So is it in total or not? Right? Suppose the prices, later you see that hotel data, suppose, right? If you've got everything but the price is missing, right? So you exclude that from the data or not? Okay. You have to make your judgment, right? When to use what, but that will be important consideration. So that's why sometimes you still look at that, right? Because you don't have to decide check the problem of missing, right? Missing something. And depend on the data, if it's pretty continuous, we will draw different thoughts, but in our class, we focus on this. Okay. And then you look at the number, right? You check the center tendency, mean, median, mode, or peak, or how they disperse, whether they're skewness or the closeness. And then you look at the extreme value, are they just error, or is it because of data collection process? Okay. So to give you a more detailed look at the case, because otherwise we will fall asleep, right? So let's look at the data. Okay. So this data is again the same thing we have is the data look at the hotel in 2017 to look at the price. So we have seen that already last time. So what we're going to do is look at histogram. Okay, we'll draw this using the Python code, but let's see what this is in the textbook. The textbook gives you this two graph, and it depends on you focus on absolute or do the math. And this we look at individual value or look at the combine it together every $20 a bean, right? So then, but this gives you the same. You can see how it looks like. Okay, almost symmetric here, but there's a little bit here is a little bit skew on the right hand side. Okay, so this is the here you have. Does it fit your intuition? Is it around the price? You can see the main cell data is around 100, right? So there's a very expensive one, right? And there's a very below 200 is not very normal, right? And above is a little bit very expensive. Right? So this gives you an idea what kind of prices you are going to expect to pay, right? And you would think if you pay more than 200, that the hotel has to be very good to justify it, right? And if it is like $50, right? If you find a deal that is less than 50, then you may worry about whether it's fake or real, right? So that will give you some idea the question you want to ask. Okay, or you can put it in the $40 bean, and $8 bean you see this kind of shape. To give you a much better idea when you keep changing the bean. So that's why you will see how it looks like. Okay, and of course the question you ask me is probably is what bean should I use? There's no hard and fast solutions I use, but we change different bean width, right? And then you look at the diagram, give you some idea how the data looks like. Okay, so I think we can go to the work. Okay, again. Okay. Well, it looks like this again, and I hope by now you should be very comfortable with this Python code. So the first numpy as NP. Again, this is nothing new, but just to recall, numpy is a numeric Python package library that you use it to do calculation because numeric NP, right? Numeric py. And second line is pandas. If you recall what's pandas, pandas refer to panel data analysis. Okay, basically just do data analysis. Okay, the first one is numerical calculation. The second one is called statistical analysis. And this data come from the website. Okay, this is live. Of course, your IT manager tell you where to get it. But see it, right? And then you CSV because that's the way to handle data. Okay. Now let's do that together. Can I copy this file? Let's see. So as I said, we should be doing some better documentation. That's what I'm doing. Okay. So we are doing this, and then let me add another. If I tell 2 sharp, there's subtraction. So this is a hotel case. That would be. This is the way that I would. Let me double click it. So I would do a double sharp, right? For a lower level case, single sharp is for the single level case. Now, if I actually run it, okay, then of course, the first thing to do, which I should have done, is look at the data, right? Maybe I just add a thing here, right? Let me have a look at the data. Let's take a look, right? And this data, I mean, this is the data same as what we have looked at last time, so there's nothing new there. Okay, so you will see the first thing you do look at the. Also, let's just stop for 10 seconds. Okay, you can set the data. You can't really do it. Raise a hand, I'll come to you. Because it's more like hand-on class, right? Yes, as an IT manager, I mean, learning the formula will not be very useful. Learning how to actually work out is more useful. So just make sure that it's okay. Maybe if you have a question, please raise a hand. If not, then we continue our slide. So here, what we do is we call the look at this by this LOC command. We just like look at the location by column, right? And what we do is looking at this where this equal to hotel, right? So this, if I run this, that's will. I will just look at the data set, and I take out only the accommodation as hotel type because look at the data. There's apartment here, but we don't want the apartment. I just want to focus on hotel. Okay. Then you can check the data again, maybe hotel, dot head. And then you will see the hotel is gone. Right. If you still not sure to do it, we can use the one hotel dot value count. I think we will do the accommodation type. So you can see data left is 266 for the hotel. Okay. So that is the slide I done, right? Let's look at this. Either check full look at data, first 5 column, or you do a CS check, right? We have seen this last time. So look at the value count on a different one. That's 266, 264 data. Okay. So now we're happy because now having hotels, and that's why I stored the name hotel. All right. So that's why you can see I try to name the data set according to the feature we can readable. Right. If that is okay, I think there's nothing new here so far. Okay. Now it's like we are doing histogram. Okay. And by histogram, I only have a price. Okay. So the first thing I do is look at the hotel. I just collect everything from the price column. Put it here. Okay. That's what I do. So I just collect all the prices. Okay. That's what I do. It's just like there. There's nothing deep in this step. If you try to do this, because only one column, you can see this. You can go to here and then see the price will be just 264 numbers. Series. Right. Let me stop 10 seconds so that you know what I'm doing. Okay. So that's the line I do is just like got them there. The price will be here. It's a series. Series is just a list of numbers. Right? Because I don't need any features. I just look at the price. Right. So it means that I focus on why I do that. Remember what I do is I look at key variable. Don't do this for every variable. Look at key variable. Is this variable make sense? Right. Is that okay? Now it's very simple. What left is we try to draw a table. Sorry, to a histogram. Histogram have to tell us how thick is the bar. Okay. Here I use 1. You can later you change to 10, 20, 400 according to the textbook, right? And then next is you need to tell them how the group is, this group is, right? So what we do, we will use the called the numpy package for numpy, and a range is to create list of numbers. Okay? You start from the beginning, it's lowest, okay? Until the highest plus this guy. Reason I do this is because of the way that it's being written. You stop until it's less than, more than that. So that's why you add them back to make sure that everything is covered. Just I don't know. There's a weird way this is being written, but and this being width is just telling you this minimum value, the maximum value. You cut it how many? Just cut the minimum value, the maximum value, and you cut it. Okay, and why you add? Just because the way that the A range is defined. So to add them, just cut. Okay. So if you are not sure what I'm doing, then let's look at this. Okay. Once you did that, then look at the beans. Then this is the number, right? It's by 1, so that's why I go from the smallest to the biggest, right? The smallest is $33, you just start off by 1, right? And go to very large, right? Suppose you change to 10. And then this one, actually, you can see the jump by 10. Okay. Is that okay? So this is how you would create groupings, okay? And then you create a group, okay? Then now we have to introduce a new package, which you should have learned in summer. It's called the MathPop Lab. It's the mathematical plotting library, which is basically creating all the graphics that require for us to draw. Okay, it's very powerful. And we will use only the sub-library, pyplot, is the standard 2D plot approach. And then you will see it's not complicated. I call it histogram. I look at the price and pick the beans. Okay? And then just give the x label, y label, title, and so it out. Okay? So it's every line I think shouldn't be complicated. If you are curious, you can change whatever you like. So I change it back to 1 first. Then this I'm not going to run. I mean, let me delete this one because I don't need to see. And once I run this, okay, this histogram is 1, right? Okay, so if I change to 10, you can run it again, right? Maybe you don't like this histogram. Maybe you can say hotel price at Vienna, right? So that would be accordingly, right? So that would be how you play around with the bin, right? If you don't like this 10, you can change to 30. Okay. So as you can see, I need to run this and run this again. So the easiest way is to combine these two codes together, just to make our life easier. So usually you will do that, right? That's how I do. Then you don't have to just click once and then you run everything for you, right? If you change it to 40, right? And then you will run, okay? You can play around the labels, and that's how. Maybe I have 1 minute. Make sure that everyone able to draw this diagram because this is very important skills. Then you can look at the menu to see how all the diagrams can be produced. But I'll just go around to check if you have any questions. And make sure that you're okay with that. Question, just raise your hand because it's more like tutorial style. We really want you to work out the graphs. And your computer, your laptop doesn't work, you can use the computer in front of you. Okay. Any question, let me know. So hopefully using this, you're able to tell what kind of shape you have, right? So that would be something that shouldn't be easy for you. Okay. Now here is I do other things, but not the price, right? I also look at another key metrics, the distance, because when you book a hotel, is you follow the distance, whether the distance makes sense. Why I want to do that? Because I want to see data we collect is correct, right? We are actually collecting the data that fit what we want, right? Should be close to the center. If too far away, then it's not good, right? So that's what you see, right? You look at this data, mostly are very close to the center, but these are not very good, right? We're far away. So we later look for the good hotel, then probably you want to exclude those data, right? You don't want to be like 10 miles or 12 miles from the city, right? Maybe at most 2 to 4, maybe at most 4, or even 2, depends on your goal, right? So this gives you some idea of the data. Then you can refine your analysis, right? Because this data with this analysis will tell you what kind of filter you want to use, right? Because without looking at the shape, you don't know what kind of thing to filter, right? Unless your boss tells you to do, right? But this will tell you how to clean, right? Because this process, B.B.A, right, will tell you how further the cleaning you need to do, right? You want to what kind of thing to focus on. Okay, so I'm not going to explain because it's the same, except we change the distance to price. Okay, so you can copy it. All right. This is the distance, right? The code. I copied the slide 15 and also slide 16 because it's a plotting, right? The first one is what I did is using the hotel data set, get a distance and use a bin. You can change the bin according to your favor. Okay. And when you plot it, it's just the when you do it, it's a plot here, right? It's one is exactly the one you see from the slide, right? But if you don't like one, actually you don't have to. Actually, can be used 0.5, right? You can use whatever number you like to create this diagram, right? You can change the label, X, and whatever according to your need. Okay. I hope that is clear what we are doing. Right, so this is a graphical analysis, okay? Although we are limit ourselves to histogram, I think you should be able to do that, okay? Before the break, I want to say something about the filtering before we talk again, because we got the raw data and we discovered that the data is still too much dispersed to be useful, because you want to find a deal, then probably we narrow down our search because it's still a lot of data, it's 200 something. So what to do is look at, say, this one. What they say is I want to focus on the hotels, and we've done already. Next is we want to focus on B and 4 star, right? So we focus on this already. So we add another filtering criteria. And once you do that, okay, you will see the data a little bit the same, but a little bit different, right? So that is what we do. And here is like I have the data that has 1,000 more, right? The graph looks like this, right? So basically, we don't want to have that. Maybe this is mentioned, right? So you really want to exclude those things. Okay. So what here we do, we just focus on 2 things. Cut it out. Okay. First is I want to focus on 3 to 4 star, because I probably don't want to spend a 5-star hotel. For example, it's like you go on business trip, then usually you cannot go for 5-star, right? So that's what you do. And then of course you also don't want to go to no-star hotel, right? The reason is being that if depend on the software, less NA is also less than 4 or greater than 3, because when they're not available, you'll be there. So that's why you have to use a special technique called not NA. Make sure that this is not an NA, it's not available, right? We're not able to satisfy this. So this is a little bit tricky part. Have to be remembered. Okay. Just to remind you, what I'm doing here is I create a new data set from scratch, of course, focus on hotel, using the LOC, right? The selection is selecting the observations, and then focus on the star between 3 and 4, and make sure that it's not NA is there, because otherwise, when there's no entry there, then this is true. Okay, so make sure that we don't make the mistake of no NA. Okay? So what I do is I just copy this, right? And then here, right? Let's run this. Oh, why is this happening? Okay. And I clean this up, right? Focus on 3 to 4 stars. And here, do the same thing. I look at the price, right? And focus on 20 beans. Okay. There's nothing new in this line, right? Focus on this prices. Okay. And same, right? 20, but you can put whatever number that you think is appropriate, right? And then now I'm going to do is I'm going to draw it, right? Draw it again, right? So so this will be the graph. Okay. So you can change the bean and then draw the graph. Okay. So if with a break, but if you want to challenge yourself a little bit, you can try to rewrite this code to exclude the price more than 500. Say the price will be less than 500. Then draw the diagram. And if you are able to draw it, you should be able to see this one. I think this one is redrawn. If you want to try to insert in the break, you can try to fill the data again, okay, to make sure that it's between 5 and 2, okay. If you want to take a break, okay, that's okay. But if you want to have fun after the break or during the break, you can do that. So let's have a break of 15 minutes. We will see you later. In the meantime, I hope that you reply, but where's the you reply? Oh, you I see. Okay. So if you want, you can leave your comment here, whether I'm going too fast or too slow. Let's have a break of 15 minutes. Let's resume at and 43. Okay. So in the meantime, I walk around to see if you have any question. You do that right. Walk around, stretch a little bit. Read the book, take some coffee, Madonna.
I have a question.
Yes.
Like, in the financial industry, people sometimes use other statistical software for frameworks. Data and R. Do you believe that data or the R equation is in some aspects better than
Our same is
the same?
Almost the same, speed wise or the syntax wise. Say that, I'll say that. So no one will say that. I'm not really going to say that.
Nobody uses it.
No one say that. No. Say that is only used when you magic coding. No one say that.
I think it's more integrated. Advanced time series analysis or something. Like, I do the same for R.
Same, but the problem of how everything is going to be. So that's a limitation of speed. I be faster than the thing is still on the side.
You cannot scale up.
Not that easy. The maximum you can go the standard way is like typically for 100 kilobytes. So you have more than that, then you go into power and go to like 80 kilobytes or 10 kilobytes.
So basically, no transformers.
Not yeah. If you really need actually kind of it's like an interesting.
So it's the same.
Yeah, same. Syntax also is so I know you don't have this summary and some industry they use MATLAB, but I would say Python. We have it. If you really want to use other languages like Julia, in terms of calculation, our open source. If you learn, but our class is not fun. Yeah. 新加坡人和trading systems， 有很多，差不多，没安全面就没有好处，可以不可以？研究的人才会打起来的，历史牌没有。我说什么时候用什么，就是把刀这种，你们一把刀的什么东西用一把刀砍，就是一把刀的菜刀，砍猪肉用修刀的，有什么好硬件？当可能登记多了是有比你在相对上面，那个图在你完整学会。你这个有参考历史的时候，还学到了他们的地方跟这个不会的话，我去做这些外面的技术，这个看他到处但是现在里面有学到一种这方面的一个用这个不好，什么这个从艺术的来说，艺术就是里面业务也没有，对对对。是个八，这已经是详细性的，它的我以为它是R，它这个编程部分原来它是 R，它使用一个 R 来画出来的 ，R 的一个风格，但是结果是这样。它那个控制性，它Python 就是 或者一个 R 3个出来，所以它的对来复习这个采访的这个它是 R 必须承认 R 的两个好看的，我们 IT manager 不是 marketing 的那个，我不是考他们有的东西，这些我是不晓得。往外我这个，哦，那个对，大概的话，对对的，对的，现在跑出来已经跑出来在跑的东西，才不复习，完全达成一个基础，一个那个标准，这个完全差。Right. So, let's look your comment. LOC is location idea. So basically, just like you you give a list of true and false. Suppose you have 3 columns, so you have 3 rows. So if you say true, true, false, then they will take the first 2 rows. So let me look at it again. So LOC, what is it doing? Okay, so let's look at this. Look at this particular thing. Okay, say if you run this particular one, say, okay, let's see what do you have. What you have is when you run this line, see, it will tell you whether it's false or true, because the first one is apartment. If you still recall, the first one is apartment, right? It's not hotel, so it gives you a bunch of 0 and 1. Means it's a true or false, 0 and 1 value, true and false value. Then what you do is look at if this is false, they will kick out from the data. So you kick out this line, keep the second one, right? So that's why when you run this one, the first line is gone, right? You can look at the where first line is this observation, right? Which is same as the second observation here, right? Because the first observation is gone. So basically just pick up the observation that is true only. Okay, I produce this line produces a bunch of true and false. This is a statement whether this is equal to this, right? It's a logical statement, right? I think you learned summer. So that is, I hope that's okay. I hope that answer your question. I'm not sure if I did, but is it not necessary to label, right? Because what I do is like can say, for example, this one, I can say, is it for 3-star or 4-star? Number is also fine. So any logical statement is still true and false. We can determine, right? For here is I have to satisfy this statement, this statement, this statement, and, right? For this to be true, right? I only focus on observation that satisfy all the criteria. Okay. So anything you can do operation, you can use this function. Oh yeah, weekend is coming. That's Good Friday. Are there more customized plotting framework? Matplotlib is actually, if you look at the thing, it's actually very customizable, but we didn't do it too much. But you look at the menu, Matplotlib is already, you can go to the very deep down, can do a lot of stuff. The next one we actually use SNS plot. That one actually is less customizable, but beauty much more beautiful. But I will tell you, this is, you look at the menu, maybe we can just show you. Look at the menu, you will see that it's huge and crazy library. And this one is very customizable. Let's show you the example. You can draw so many stuff here, right? You can see this is many types of graph you can do. You can 3D can do it. So I guess for the purpose of creating graph is already, this one is already look at the gallery, I guess. You see there's many type of graph you can draw, right? And usually what you do is go to a gallery and pick up the one you like. Let's say, suppose I particularly want, I don't know, this guy, and then you go inside and see the menu and then you can do it, right? As IT manager, I hope you will not find it difficult, especially we run a lot of things already. Okay, so of course we only scratch the surface, but I hope this framework is already very generic. I guess for IT manager, you don't really need it unless you're really doing something for a very exceptional graph. Wow. Yeah, morning class is sleepy. I mean, I can see some of you listen to my advice, have a lot of coffee on the table. Yeah, you really need a lot of coffee. I did have a lot of coffee this morning. It was Friday, right? Yeah. Oh no. We still have one day, it's Monday. We haven't weekend yet. Oh, me. So it's Friday, okay? Just make sure you don't make a mistake. Is it rainy? Okay. Today should be very unambiguous, but okay. Yeah, just use the Matplotlib to draw it. Can't average EDA. Yeah. I think you're doing all right. Most of you know what's going on. So four of you think I'm a little bit, speed is a little bit fast. But in general, it's okay. I mean, so AC is not that cool. Okay, good. Oh yeah, Friday morning. Yeah, that's good. But I know that afternoon you have some more classes. But drink more coffee if you need to. Oh, okay, I like this one. I mean, I guess I fall in the trap once. Hopefully I don't fall again. Oh, good. I guess most of you are okay. You're following. So I hope you're done. So let's do the second part. Is we have to look at the graph and give you some idea, right? But sometimes you want something more than graph, because graph only tell you as much as I can see, right? That some number is very helpful. So this is just a review of what you should have learned in the undergraduate. There are many ways to summarize the data, and I guess you would know most of them if I write in Chinese, but just very quickly go over that again in English, right? The center tendency, right? It's just a bunch of numbers that if you are only allowed you to use one number to represent the whole column, that's what we do, right? You use the mean, median, and mode, right? By mean, just adding everything divided by total of them, right? Just to remind you, the mean only meaningful when talk about numeric data, right? The cardinal data has no meaning. Don't calculate average stars or hotel, which usually have no meaning. You call median of the star will be fine, right? Because middle guy is still meaningful thing to say. Right? And mode always meaningful, regardless of what data you do. It's counting. Right? If you can't count, then there's no statistics at all. So the first feeling, I mean, this first feeling is a thing that if your boss or you want to tell others, this is the most basic thing, right? And of course, I didn't talk about that, but this number will depend on how you clean up the data, right? So suppose you clean the data, then this mean median mode will different. So you have to be careful what actually you're reporting. Is it raw data? Is it the filtered data? Right? The second kind of data is location, percentile, quantiles, right? What does that mean? Is like instead of reporting the middle, median is reporting the 50%, right? Or the second quartile, right? Or you can report top 90% or bottom 10%, right? Or 99%, right? This kind of number, percentiles or quartile, the first quartile, the third quartile, so on and so forth, right? Quartile means you divide data into 4 equal parts, right? Where you have the first cut is the first quartile, second cut is the median, the third part is the quartile. In Chinese, I think it's 四分数 right? 平均数、中位数，还有一个我不知道众数的，I think that's correct. And the next is called dispersion. Okay, dispersion is the one that try to give you how precise the center tendency is. Because I asked you, right? If you give me a date number that summarize your column, you use mean or median or mode. But the question is like how accurate this number is by dispersion, right? If the data is very diverse, then this is not very representative. It's not very useful. So the common one you probably have learned is variance, Fang chart, right? And then deviation delta chart. So this is the two things, right? But other than that, you can use range with the max minus the mean, right? It's 90%, 90, 10 percentile range is top 90 and then bottom 10 to the difference, right? And then the interquartile range is like 75% minus 25. right? It's IQR, right? And the last one is coefficient variation, which comes from taking a standard deviation over the mean, right, the CV. And probably ask why we care about the CV. The variation, because when you compare across data set, you need CV, right? Because they're not the same mean, right? And not across the data set. Suppose the one you're doing for e-marketplace, look at data, right? Look at the sales variation in the morning and at night, right? And the different timeline. You can probably claim the at night have more variance, which is true because people can spend more time on the web at night, right? But when the variation is larger, but you have to normalize or correct it by time, so you have to normalize it. The last two is something that probably you might or may not learn in the undergrad. It's called skewness and kurtosis, which skewness is telling us whether the data is symmetric, right? And kurtosis is asking whether there's a fact tail there. A lot of outlier, so we outlier detector. Okay. The kurtosis is like more than 3 or less than 3, right? More than 3 means it's an effect, less than 15, right? So the reason why we care about skewness and kurtosis is because of the standard technique that apply to our analysis doesn't work if data is very skewed, right? By skew means that too positive or too negative, right? Around skew is good. Kurtosis more than 3, less than 3, right? If way more than 3 or way less than 3, then you have to apply other techniques there. Because a standard inference doesn't work, right? Later you see maybe you need to bootstrap an error, or we do multi-cardinal simulation, or you cannot really do, you have to focus on clustering, or you can do regression tree, those kind of various techniques you apply to make sure that everything looks nice. But I just keep it here because we're not that class. I just put here because you may know or you may need to know when you actually run data. Okay. And just saying that it's supposed kurtosis is you are going to take an outlier, right? Remember the example we have the hotel price data, right? If you look at the skewness or kurtosis, all the data can be large. But when you cut out, say only focus on hotel, only focus on 3 and 4-star hotel, and maybe even cut out the price, right? Focus on hotel that's less than $1,000, then everything will look nice. Okay? So these are the things that in detail, right? Because here, remember when we cut things out, this look nice, right? But how nice is it? You have to come up with a number to support is a nice thing, right? One thing to look at the mean, the variance, kurtosis, skewness, all this kind of measure. But it's not. We don't have time to go over what is normal, what's not normal. But I tell you already what can be there. This is a summary of the number that I mentioned, right? Because now the internet is so convenient, I'm not going to go one by one to explain them. You have already done that. But there's a lot of formula, and the different type of formula you can use. I guess it's very intuitive, and then you have learned it in the undergrad. I'm not going to go into detail, but in case you are still worried about them, then you can just ask me or ask a TA for further details. But AI is so convenient, you can use ChatGPT to tell you what to worry. That being said, I would like to point to you that how we can use Python to actually calculate those numbers, right? Here I use the X, but you can use the hotel prices to do the same thing here, right? You can, what I do is I use the library called the library. It's a basic library. Why I do this? Because this library doesn't need to install. This library comes with the base Python. So we don't need to worry about the installation. And you can see it's very simple. We have mean, median, mode, more than one mode, right? Max minus mean. You have the quantile. You can use variance and standard deviation. Okay. So one thing I have to focus on to tell you is there's p variance and normal variance. This is The difference is population and the sample version. It's when divided by n or divided by n minus 1. Right? And when to use what? I think you run under graph. But the main thing is if you want to use your data to estimate, then use this sample version. 样本那个方差那个 I don't know what it's space. But this is how you would do that. Okay. So this is the statistics package. But we will not use this one. Instead, we'll use the other one. That is the SCI PY package. This is the most the thing that we focus on. This we'll use SI, the science package. Use the stat, okay? And later you will see when you do machine learning package, we also use SCI PY. So this is the package that we will be using a lot, okay? So we will use NumPy, then we will use call the NumPy.array. It's just like the way you declare them. You don't have to do that, but make it easier, okay? And then I'll use the because NumPy already is a calculator library, so that's why you cannot give me NumPy median or give me the data. But more have to rely on the stat library. Okay, the max, the mean, the range, P to B, the point to point, and then percentile is you can also use the IQR variance. And there's a little bit tricky part is the variance formula. Population one, you don't need to do anything, but the sample one, you need to adjust degree of freedom. Okay. Then that's why the DOTE is 1, it's -1. So this is how you can run this. So maybe I just copy it and run it in my file. So I can just run it. So you can see, although I run a lot of line, I only give you the last output, which is a standard deviation. Now I want to suppose I want to go back to the price, okay, the hotel data. Okay. And I run this will give you the mean, the price, right? If I want to care about the variance, the price, okay. Maybe I look at the sample version. Maybe I just document that, right? Mean of hotel price, right? That is the sample and the deviation. Some SD, maybe I'm just being lazy. Okay. So this can generate what we want, right? And if you want coefficient of variation, that would be this minus that, right? If you still recall, that's how we define CV, right? That's it. Sample CV of the price. So that is how you can calculate all those. Right? So any that should be easy for you. Is that clear? How you're going to do that? But of course, this number will tell you something, right? You will see, okay, is this price peak our iteration or the average? Is it 1 to 20 US dollar? The price is it the DVA, the standard deviation, 82? Does make sense or not? Right? Then some idea, right? The variance is a little bit too crazy. Oh, sorry, I should be SD is not this one, right? Not variance. I think it's STD. Sorry, this is the variance. So the where the standard deviation is like 100. It makes sense because you can see it's 100,000. Sorry, is 10,000 for the previous one variance. So I noticed that a mistake, so that's why it's. Is that clear? I mean, I hope this is clear now, how you can apply the thing and then they compare contrast. Is that okay? So I hope this shouldn't be an issue, something that you learn undergrad, but we just put in the Python. Is that okay? Is that okay? Just go around 10 seconds, make sure that everyone is all right, because we cover so many things. Stop your time. If you forget about statistics, that can be difficult. Okay, then I assume you're all right, since no one raised your hand. So this is the graph. You can draw a box plot and volume plot to see how it looks like. It's similar histogram, right? If you like this style, you can have that. But it's convenient because when you compare different data sets, you can draw different box plot together. Okay. And the volume plot is very similar. I guess it's self-evident. You can look at the Matplotlib how to draw it. I don't think we spend time on that. What we're going to do is look at the data again, but you are now comparing two data sets, which is London, the other is Vienna, right? And this is the data, the same thing, but we add now a London. Okay, and we focus on 3 to 4 star hotel price below $1,000. Okay, so that will be the goal. Okay, so you can see the data is look like this. Okay. So we are trying to generate this graph. Okay. So what we're going to do is we need to use called lumpy and pandas, because panda will allow us to download data. So we download data from your price, and this is the price data. Okay. And next, a little bit tricky is I have the hotel features. Okay. Because each hotel, they would have features of how many, let me look at data. Okay. So if you look at data, they will tell you, okay, what's the rating of the hotel, where's the hotel, what distance, right? So this separate two tables, right? This is the hotel feature, right? But the other table they have is just the price data. So look at this one. So the price will only tell you, okay, hotel ID, year of price. Okay, so this is usually the data being stored, right? You have two data sets. One is look at the prices they have, which may change depending on date and year you collect, right? And the other is hotel feature, which is not changing, right? No matter which day you collect, the hotel features will be the same, right? Or more or less the same, right? So you will separate two data sets. Okay. So that is the one. This is more realistic, right? Because the previous one you had is everything is pulled into the same table, but in general, this is the table you have. Okay. So what I do is I have the price data, sort the price data frame. I have the data for the feature and store in the feature frame. Okay, so that's what I do. Okay, let me copy this guy and put it here. Okay, and I run this. Okay, and if you worry about it, then let's look at the price dot head. Okay, and run this guy. Then this is something that we have seen. But let me wait 10 seconds because you may need to run it together with me. Well, we just copy the code, and then I just download the two data set and I check if the price data is correct. You can go ahead and check the feature data is correct or not by doing feature.head brackets and then see the data is what you want. So here I use another function which you may guess. I use head, but I use tail here, but head is from the top to the end, right? I look at usually 5. Sometimes if you are curious to look at the end, look at the tail, right? See where the I can change the head as well, but say I can look at the feature. There's another function that actually I should have introduced earlier, but this is the head, but it's not the end. So just want to see if everything's all right. Okay. And you can see this each hotel is just like not just Vienna, right? Just every hotel in Europe, the European features. Okay. If that looks all right to you, so now we are going to show you how to combine 2 data sets, but now not one map to one, right? Because remember, you will have the same hotel can appear many times because of price. Look at this data. Remember data price? Hotel ID 1 have different prices depending on the date, and then here you collect. Right, so same ID will have many possible number. But look at the feature. One ID only appear once, right? It's a map. The ID is the ID, the number that map, right? So it's like you want to the price, you want to append the feature on the price, right? So it's a many to one mapping. So what I'm going to do is use the function called merge, left merge, because we want to match every of the left. So that's why the merge is called. We want to merge 2 data sets. Okay. Every of the left have to be merged. So left. If you swap this, then we use right. But let's look at that. Make our mind easier. Just keep one side, and then match on what? Hotel ID. Okay. Let me repeat this one. Is based on hotel ID. I want to merge these 2 data sets. Right? How I want to merge? If it's 1-to-1, that's fine. It's still even right. But because of price, right? You have many columns as one, but same ID, right? And this one is very unique, right? Once we just merge on the just like that. Okay, it's a many-to-one merge, right? But if this is the 1-to-1 that's joining, done, right? But we don't have 1-to-1 matching, so just like that, we use this thing to do it. Okay. So let me run it. Okay, I just combine this one. Then let's run this. I combine. Let's merge this one. And then once I merge, it takes some time to merge. Once you merge, of course, you want to look at the head or tail. Depends on. Sorry. Once you merge, you will see the thing is hotel ID, right? Then you can merge this new thing, the country, city, rating, so on and so forth. Because the first 2 rows are the same hotel, so actually everything here is the same. Okay, that's how we are merging that. Okay, so that's how show you, right? How we merge the set. It's very common operation. You combine them together, you do analysis, right? Because then you can focus on the star rating and filter, right? So we just like we do things slowly, step by step. Is it okay? While we run this line, then quick. Is that okay? If okay, then you will see I have 2 more lines of code here. Now because now I have a combined data set. Okay, so the original one that is no longer useful, I just delete it. The reason is because you don't want to clutter your working space with non-usable or non-user data. Just take it out from the thing and clean that up. Okay, so that's what I do is because I don't want them anymore. So you can try to see right here when you open it. it's a bunch of stuff. It's a lot, right? So I just want to keep our desk clean. So just I delete them. Once I click run this button, the price and the feature will be gone. Okay? Because it's a large data set, right? The price is more than 100,000 entries. Right? The feature also have 20,000, right? So then once I delete that, then they're gone. No, they're gone, right? So they're gone. So you just save some space. This is usually you do, right? Once you have import data, it's really huge, right? And then you delete that. Okay, because once you combine, you'll be gone, right? So you always keep your memory clean. Now you can see I have something crazy going on here, but it shouldn't be something difficult. Okay, let's go line by line, and you see what I'm doing. As I said, LOC is selecting a column based on true and false. Okay, the first row say I want to select only the year 2027, sorry, 2017, which is easy, and I want to select the month, and I don't want weekend, so I only weekday, right? Of the November, and here's a new function I call is in, which means that a very simple thing is I'm asking the city is either Vienna or London. Then I don't want to look at things outside. So it's is in is this or this or this or this. Anything is or. Okay, this is n. Of course, if you like, you know logic, then it's like I can use this or this, but is in is more clear, right? Instead of writing a multiple line, right? You can is in is convenient, right? Just say I want either the city is in this to one, and I only want hotel. This 3-star and 4-star already seen before. Not any already seen before is the same, just like selecting this one. Okay. And this line is as we said, we focus on the hotel, the area city, but city actual is the smaller one, right? Remember the Shanghai and Da Shanghai, right? Shanghai is a small area, Busan is much bigger area. So we want to focus on the real one, right? So that's why it's in, right? So just like Meicheng Yuanyi, right? It's like whether it's Hong Kong or the Hong Kong, the brand name there. So price is 600. So there's nothing new, right? I mean, although it's a humongous object, all right, looks like crazy. But if you do it line by line, there's nothing new, right? Because for you, maybe IT manager shouldn't be scared by that, right? But we have to go line by line to understand what's going on. Okay, I hope this is clear what we're doing. Do we cut it out? No. Run it, there's no problem. So everything is very nice. Of course, other than you can look at the mean, you can look at standard deviation, all those kind of things to see whether the data is all right. But I assume we've done that nicely because it's given by the textbook. So this should be, this filtering should be fine. Okay. And what we're going to do is two things. First is look at the Vienna data. Okay. So what I do is I focus on Vienna and call it Vienna and look at the Vienna price. And I use the bandwidth 10 and then try to draw a histogram. Okay. And I think this part should be something like shouldn't be very new to you. So I combine this cleanup thing, okay, together with drawing on the same one. Okay. So it should be Vienna. Nothing new here, but just saying, I just show you how you would start from the beginning. Your data set you combine, clean up, and filter and draw. Right? So it's very full step there. Right? Of course, if you don't like this, you can change the bandwidth. you can change your filtering method, and you can do all those, right? Okay. If you don't want the price, you got a distance as well. You know how to do that. Okay. Not going to go point by point here. Okay. And you will, if you see the slide, once you do this, I will do London again, okay, London price. So the only change is I have London and I call the data London and do all the same again, which is relatively tedious. Okay. I run this and then I will stop a little bit. You can work out on your own if you want to, but there's nothing where did here. Just London histogram. So this is the price for the London, very different. But let me stop here for 1 minute so that you can try to create your own based on your input and see whether you're doing all right. So you can see we do step by step from the source data combined together and plot. They can compare. Probably from this graph, you can tell me the difference between London and Vienna price. Right? You can check. And you do notice one thing, if you are not careful enough, is look at the very left-hand side. This is not the absolute frequency. How we do that? If you are careful enough, we do the density. It's true. Okay. As an IT manager, you should be aware of that. But if not, then your eyes have to be trained to be more sharp. Okay. So that's how you draw a relative density plot instead of the one. And you do notice that when we draw this one, we drop the NA. So that's why the relative is when the price is NA, we take out of the total. Okay. So have to be if you remove this one, then you will be an absolute value. So let me do it. So suppose I don't have this line, I run it, then you'll be absolute value. Right. So if I go back here, if you do false or true, depends, right? Whether you like, and then you go back to the question why we want to do a relative one, because I want to compare two siblings, right? You compare absolute, that is not, it's okay, you can see the thing, but if you want to look at the shape, then it's less misleading. You focus on the relative one. I hope that is clear. Oh, sorry, that's it. Great. Sorry about that. Okay. Maybe give you a last 2 slides and then we'll break. Sorry, go around a bit. So you have histogram, but sometimes you want to do density plot. I'm not going to talk about it in Python. You can look at the menu. It's easy to plot. Just you change this histogram to something other than that. Then you can join histogram, density plot, and you overlay like this. I mean, as a programmer, you should know how to do that. It's not something big. Okay. But the good thing about drawing this is you can overlay so you can compare. Right? The density, right? So you can see London is more evenly distributed, it's more spread out compared to Vienna. But okay, at our graph, even though you can look at this already, right? It look like this one, the Vienna, and the London like this, I think you can also draw the same conclusion. There is no, but this is more direct because they combine together. Okay. If you want, you should try to draw this on your own. Okay. Using your technique to write. I mean, it's not like you can go home and do it when there's a weekend. You have fun for that, but that would be more fun. Okay. So let us have a 15 minutes break, and then after that we come back. Then you end this chapter, and then we go to the next one. Just to remind you that I forgot to upload. I do today is this slide 39 to 49 will be considered technical, so you will not cover it. because there are probability thing. I don't think we need for only for a class. I should the revised version I will put on the web. There will be I put all this from 39 to 49 will not be part of our syllabus. Okay. After the break, I will cover 50, 51, and 52. Okay. Probably you ask what are the 39 to 49? Say this is a thing that usually you use it to model things. Okay. And in the real world, the data may look very shape, right? Then you may want to fit it to a distribution. Then you can easily do estimation, do prediction, all those kind of things. But since we are not doing this anyway, so we just give up because estimating this requires what we learned in maximum likelihood estimate, those kind of things, which is beyond our class. So we just save this key because even if we cover this, it's not going to use anyway. So why bother? And since we're not doing machine learning, so these I think you can say this old thing, old machine learning style. Old way to because we try to summarize the data using one or two numbers, right? Try to fit the model. But now you learn the machine learning method is like a better way to do what we're doing. So that's why we're not going to learn the old technique. We learn the new technique. But anyway, so let's a break of 15 minutes. Let's come back at 11:41. Okay. Again, I will open another. I don't know. I forgot the word count. Right? Nothing. I open another one so that you can. I think you can do the second break. Okay. Only 5 questions. One, in case you want to say something, okay, you can say. And if nothing to do, you can try to draw the density plot. You look at the menu if you have nothing to do. Of course, you should take a rest. Unless you really want to. Can go around to see if any question. And 40. 11. Okay. Take my one. Take my dog. Go to your oh, on the law. Take my one. Or on the law. Oh, sorry. I mean, we'll go on the law. That's okay. 今天有教授这个把一个难度点它大家就能大家就是太老家了，我这个太累了，所以对我来讲，做一点风格是大家轻松。今年的话，看他们看我们一年，还是差一点，对吧？对，不能说讨厌。之前大家都饭，我也吃完饭就在上手，今天给大家发这个心就很深刻，上下上来就发出来说，或者是口音，他们好是好辛苦啊，会不会少一点？然后这样训每个人，然后点好就不太。最后投诉，开始的话大概就是这样的在 slide 这个上面，对，念的 slide 跟 slide，念就行一下，很简单，很简单，对，来，我也知道，这个后来的东西来了，我来来。时间上比较紧张，现在找结果比较时间，必须得大个小班长，有点难。别人看这个时候，对啊。我们就很好，这客人从看第1年是开始，第7、第8那就是正常的标一个包，标的包，在你的学证学的时候是大的学习，专门个人状态，你可以影响，不管是法律，或者美国以后第一马上，也没很远。我属于一些东西，因为里边是怎么生的，回归什么的是简单的 model， 所以是都一样是一样的，而且比较大的一点，海报上的里边是也是不是可以。 neural networks. 现在我们讲说，不一样。他们都是地方，大部分都有对啊，这个这是主要是一直没有流行过电脑的哪里，这个neural network 很多年前，这本质上是我看你看你不看好吧？应用也看 C++，我的不叫你说应用是，如果你说应用是在商业社会应用，不是很多。但是如果你是真的是 AI 啊、长期学习大的，大家说的是一个。不是说越厉害的东西越好，没有用。就刚才说的，你怎么切水果的话，切肉的，是用什么情况？有个很有这样，所以我们要发展3周的。没有什么关系，都是交不到嘛，对吧？So I guess we can check. So how to draw density plot? I didn't cover, but because of time. But since you are able to draw like this kind of plot, okay, you can just plot it. Density plot. CDF like this, you could able to draw out import this thing. Shouldn't deter you, but if you still don't know how to do it, you should able to do it using AI, right? Tell you how to do it. We already tell you how to do it, but the only difference is like, okay, just give the hints a little bit without just brush off like this. So basically just change something to draw that thing. I'm not going to tell you because you should be able to do it by yourself, right? If I tell you every single step, then it's too much spoon feeding, right? But if you really stuck, you can ask TA and me. I mean, I'm not going to let you hang there not knowing, but you should try to look at it. If you still don't know, then just ask. Okay, but I don't want to really tell you every single thing. Then seems to be not helping you. Yeah, mention to table. Yeah, visualize. I think you do it very right. That's it. Yes. So basically, what we do just in the first 2 hours, right? Just have the data. You can summarize the data using some statistics, which you know how to do it, right? Just use the SEIPY package, right? Or NumPy package that can do it. Or you can do the graphical case. You can do a histogram. You can draw all sorts of plot. Okay. I mean, I can't really cover every single plot, right? But you can actually do that. Use the plot, whatever. Okay. Whoa. This is very interesting plot. So it's an increasing the speed. This is the first time I saw this one. This is very skill version. Okay, so far it's okay. But just I mean, same as all the class at master level, right? You don't expect to understand 100% of what I said. You grab the main thing, right? And then the rest will be, you can just look at the book or use, now the AI is very convenient, right? So you can just go back, or it's because this class is record, you can go back and check the video. Of course, you can ask TA and me in case you're confused. When we have makeup, I think I put it on the announcement here. I think we are this class, right? The makeup I make up same day, because I'm sorry, 18 I will be Macau for a conference, so I can't be physically here to do the class, so I will just move on Saturday. one setting. I mean, in case you really can't come, you can just on Zoom because I allow you to attend by Zoom. But not in this room with MWY. Just to remember to bring your laptop in case. But if you really busy on Saturday, just attend by Zoom. I have absolutely no problem for that one. I hope that will ease the concern with the that, because I'm very sorry about that. But I mean, I have to go because I already say I will go before I say this class. One thing I want to ask your permission, because I noticed that our class is slightly fall behind the schedule. Then I think that if I do the quiz in the class, then we don't have enough time. So may I suggest that we do the quiz at home? So just multiple choice, you can do at home at your own pace. So if you are okay with that, if you disagree, then let me know. I mean, you can go back to the class version. So just you do it, you should be able to get the full credit, as I said, right? So now, okay, because take home, so you will be if you do it, you get the credit. So basically, I will give you like 10 each class. I give you one quiz, maybe 5 to 10 multiple choice questions. Just whenever you do it, you get the credit. Okay? Even though you get it wrong, doesn't matter. But just do it. I mean, just try to do it. I mean, I can't monitor because you do it, you get credit, right? So, and then make it easier. Okay, if that is okay with you. But of course, if you strongly against it, I can go back to the class. But because of the time constraint, I noticed we don't have much time left because this year we do more hand-on Python class, so that's why we have less time. So if you're okay to use this, I'll do it instead of the quiz. I will do the take-home one. So just go home and take a look. Okay, you can let me know next week and see what happened. Okay. The next will be like this one. If you want to create this table, right? This is just collect everything there, right? Calculate the mean, median, max standard deviation. But I guess we are able to do that. And there are packages to produce it directly. So that's why I'm not going to go into detail of how to create that, but you should be able to come up with all the numbers without any issue because you know all the formula. And as I said, 39 to 49 will be excluded from our mind, so just forget about it. So if you want, you can take a look, but it's not important concern for our class. But just you will use them when you are engineer. Actually, engineers do a lot of this kind of modeling, but since we have machine learning, so this thing is we don't need that. So we focus on now the graph and table because of we have said, right? We know the graph is very good for visualization, and we already seen also table is always so very useful. So just make sure that when you write your report and you present, okay, try to use as much table and graph as possible. Reduce the number of words. Okay, you can see my slide. Follow this process. I try to make it less wordy. That's very important when you try to do presentation. And that's the probably reason why this class is taught by B school instead of the engineering school, right? Because we learn our expertise lies on how to present things in a nice and presentable business format instead of technical report. So this good graph telling you how to draw a nice graph. And actually, Matplotlib is a very nice program that actually you can if you dig deeper, actually everything can be customized. So in a class, we don't have time to go over every single detail. You can check with AI, or you can ask me later if you want to. But that would be the tailor-made. Look at the graph with a purpose to the audience. That will depend. You will determine how deep the level of the details of the graph you want, right? What kind of graph? Whether you want histogram, where you want density plot, where you want cross plot, right? That will be important, right? The access, right? The graph title, legend, fonts. and notation. Okay, just remember a good picture actually worth thousands words, and also helpful to illustrate your point. Remember at the end of the day, you want to use the data to take decisions as a manager, right? Either you have to satisfy the requirement from higher management, right? The CEO, the CFO, they want them to take action based on what you analyze. Or you want the data to convince your subordinate or your stakeholder, this is good, right? So they don't have actual data. You have to tell them what you found, and table and graph is the best way to illustrate their point. Okay? And table the same, right? How you use the highlighting, how detailed one number, how many different places you want to show. These are very important. You don't want to show everything there, right? So this is very important. But I'm not going to go into detail, but actually these, I would say, more important than your analysis, right? How to present your work, right? You may or may not notice it, but if you go to work, then you notice this is the most important thing. Is that okay so far? Of course, I skip the idea of telling you how to draw 10 types of graph or how to create 10 types of tables. But as IT manager, you should know how to do it, right? I tell you a few examples, and the rest you can figure it out, right? Shouldn't be a big thing for you. Okay. Of course, if you want, we can make it as assignment, but otherwise, I'll just leave it for you to explore. Okay. If many people ask me for the assignment, ask me by email, then I'll probably take the assignment, but if not, then I'll just let you have fun by on your own. So as we hint that we do the exploration, right? The next thing is look at correlation, right? Because so far what we've done is focus on one variable, the key variable or the key explainer variable, right? We didn't actually explore how different variables are related, right? We look column by column separately, right? Look at the price, look at distance, right? But stars, everything, look at one by one. But now we're trying to connect them together by looking, compare them and correlation. So that's something we do. Okay. So as we said, there are two things, right? We want to first, very simple thing is predict Y based on X1, X2. So prediction or correlation. The idea is, again, we don't say X1 cause X1, X2 cause Y, but it's a prediction. Okay. And actually, this is the goal of machine learning. Right? We don't actually ask ourselves whether X1, X2 cause Y. We say X1, X2 is associated with the level of Y in this one, right? So we're not going to say if we change X1, that's going to Y, right? But that will be the goal of number 2. Change X1, X2, X3, is it going to lead to Y? Right? So there are two different ideas, right? And we will learn that in the, I think, class 2, 3, 4, 5, 6, 7 for this one, and the last 2 we will focus on goal number 2. And so when I say machine learning is good for prediction, means machine learning is not good for causality. Okay, so we still need a regression to do causality idea. So that's why but regression is one way to do prediction as well. So but anyway, we know it when we actually got there. But there's some idea that what we're doing actually the rest of the semester is going to focus on goal 1 and goal number 1 and goal 2. Get the main goal. Of course, we do other things as well, but this is the main thing. And the one thing that is the most complicated when we try to discover how X and Y related is there's more than X and Y, right? So that's why we need to say, have to hold other things constant to do comparison, because things are changing, right? Because you collect the data, look at the guide, the purchase history, right? And there may be things changing, right? Maybe it's Saturday, maybe weekend, maybe during the day of the week, different time of the day, things are changing, right? Are they going to affect your purchasing behavior, right? Or going to serve your web, right? Look at what he do and then actually depends on day of the week, right? Maybe it depends on time of the day, right? Maybe it depends on what he has done, right? So have to be a little bit more careful, right? So then we have to hold things constant. And we will do the first thing, of course, we will have two types of things. One is we will look at the graphical analysis, it's the cost scatter plot, which you have learned, right? I think it's Lisan too. And then we will also look at number. Later we will learn we call covariance or correlation coefficient, which we will talk about that. So we have two different methods. One is the graphics, one is the number. Okay, so we do the graphic first. So look at data. So what we do is we go back to the data we mentioned in the class 1. It's called the management score. Look at how different firms in the world, the management style and management technique to the management performance. Okay, the data. Okay, well, I think we have seen that already. So what we do is look at the data and see whether the management practice best is 5 versus 1. And how they do that is just like whether they have the score will be 18 entry, 18 column. The management score will be average of that. Okay, so that way 18 dimension, right? 18 column. Each column will have either 1, 2, 3, 4, 5, and the management will be average of 18. And we focus on particular data. We focus on Mexico, particular year, 2013, and the employee have to be 100 to 5,000 because I only want to focus on the first some number there, right? And the sample size is 300. Not a lot, but sufficient to tell what we want to do. Okay. So first look at data, as we have done previously. We'll look at this histogram on the score. And then next we look at the firm size is from small firm to big firm, right? But we want to focus on 500 plus, 300 plus, 400 plus. What did I say? 100 plus. So which means that we will actually drop the first, some of the first part, because there's many small firm here, but we want to take it out. Okay. So what we're going to do, I think now you should be very familiar with this one, right? NumPy, Panda, website, and download. That's I copy it. Sure. So what we're doing is we're doing chapter 4. Right? And then we'll do the management case. Okay. And then we just copy and run it. Right. Although we didn't do, but usually what you should do is to check you have downloaded the right data, just ahead there. And then see if this is what we want. This, you see the whole data is still the same, right? Data with the filter to get the massive out and all the thing, but this is the data we have. Okay, let's have 10 minutes. Sorry, let's have 10 seconds before next. So make sure that you know how to download the data. Although you get there. Done. Okay. It's download data to your system. Okay. And once we did that, as I said, we have to focus on Mexico. 2013, the employment size of the firm is more than 100 and less than 5,000. And since the data is from database, so this employment number should be a number there. You don't have to do no NA because it's there. Right, so that's done. So you don't need to worry about the NA thing. So this, let's copy that and run. Okay. And now we actually select the sample according to the requirement. Okay, that's good. The next step is, as I said, we want to draw the management score. Okay. And this is the management score. I think X is not a good notation. But anyway, just being lazy. Okay. So this is the management score. Okay. What I do is I call the Matplotlib library and I call the management score column. And because of the number is 1 to 5, right? So just 1 to 5, and the width is 1 to 5. And then I just plug it. Okay, so it'll be like this. Okay, the score is 1 to 5, but you have something in the middle. Why you have this? Because every entry is 1 up to 5, but it's average of 18, so you will be some decimal number there. Okay? Unless you got more than 5, right? So this will be management score. I just put it there. I think there's a issue of this thing to make sure that it's all right. I'm sorry for the typo, but to make sure that this the apostrophe is the right one, because I'm sorry, because PowerPoint automatically correct when you go to Microsoft Word, I forgot to auto-correct it. Okay. And then you can do the same for the size of employment. You can plot it as well. So you should see this. This is the style, right? It's number of employment. So actually, we can plot these two graphs, right, without any issue. Okay. See if you're okay. And I plot it from 0 to 5,000. Each speed is 200. So you can change this. I do it because I think I follow the textbook graph. You know your concern. I hope that is all right. If okay, then you can try to calculate this mean, median, or standard deviation. Okay, let me try to do that. And maybe I just do that. Okay. Now I do that. And mean, how do we do mean? Okay, just show you how to do it. Look at the mean score. Is it a median? Now we go back to the slide where look at the mean. Okay, look at this one. You can do mean and NP dot mean this, NP dot mean that, and then NP dot SE. Okay. So we will put NP dot mean X. So 2.9. Okay. And then you can also do NP dot, is it variance or median? I forgot the thing. Median, right? And standard deviation. Median X. And then I do the NP dot ST. SCP. Is it right? Yeah, so that should be the same as here. Okay, so you should be able to do that. I left you to try the firm size. In 1 minute, you can try to do the firm size to confirm that it's the right thing. Okay. You're able to come up with what is the mean of the firm size, what's the median of firm size. That should then be concerned with you. Okay. Okay. So go with the firm size, the mean. Maybe go back to here, maybe because you're working on, so this is the line I'm using. I didn't put it here because I thought it would be gonna be a different, but because of that back to this. So okay, to able to generate those. Any question? Is that okay? Now, hope you know how to generate this mean and median. Otherwise, now the next is instead of picking the arbitrary mean, actually what the book do is they derive the data into 3 different types of firm, which is small, medium, and large. And then they want to look at what we call the lean median score, means whether the management is fat or thin, is like 1 to 5. Okay. So what is doing here? I hate this Zoom thing. Okay. So we're trying to see what is the score of firms of management score within this B.B.A. Turn out to be the bigger the firm, they have high management score. Right? The small one is 2.63, bigger one is larger, the large one is way up. Okay. And which we calculate later soon. Okay. But at the end, okay, we want to show you this diagram. Actually, you can draw in Python. But you will see, right? The larger the firm is, the more likely that they get better score. Right? Which is not surprising, because why the firm become large? Must be their good management. Right? You cannot have a very big firm just hire a lot of people. It must be a good management practice. So it's not surprising that you will see as the firm get bigger, the more likely to get better, right? So that is from our intuition, this is right. So we want to produce this type of graph by grouping data. So what we learn from this one is how to group data. Okay? The syntax is a little bit crazy, the Python, but so not crazy, but we will try to explain you slowly, then you know. Okay? First, what we do is we use the create a new column called employment free beans. Okay? Based on employment, we cut into bean. How we do is we will do a what we call NP dot where. Okay, not Henry or where, but it's NP dot where. It's where. Then you will say, the syntax is like this. You have a condition, you have a logical statement with a true or false. If true, do the first one, otherwise do the second. So it will be, if it is less than 200 employee, assign one number, or I think NA, or NA later you will assign another number. Okay, look at this. A second step by step construction, you say if it's more than 200 or less than 1,000, you put 2. Otherwise, you put nothing. Okay, and then look at this. When more than 1,000, you put 3. Otherwise, we put what we have. So just step by step, right? The other 2, if not 2, then you follow that step by this, and then you build on that. Is that clear? So it's a step by step building construction. Let me repeat because it's important. First, how you build up 1, 2, 3, right? So what we want is actually Below 200, I want to assign 1. Under the 1,000, you want 2. More than 1,000, you want 3. How do you construct the 3 step? 1 is saying when less than 200, you put 1, otherwise put nothing. The second step is 200 to 1,000. You put 2, otherwise you put what has before. So what's before is either 1 or nothing, right? And then what's left is the last thing is more than 1,000, which is nothing before. Now you put 3. Okay, so that's how the 3-step approach. I hope that convince you. This is the right way to go. So if you look at this at the end, you will see this. So if you do that, understand? So you will see at the end, you go into 1, number 2, number 3, number 1, 2, 3. Right? So that's how you combine them together. Okay, so that is how you would cut this off. Of course, you don't like this cut off, you can change, but this is how the design. This is 3 different beans. Okay. Now, what now we're doing is, sorry, is a little bit more slide here. Okay? So what we're going to do is, I want to look at observation because I only look at 2 scores, the mean score and the employment, right? Is whether they're group 1, group 2, group 3. I just keep this 2 number there. Mean is a national practice, and then look at, I group by the beans because I want to each bean, I want to calculate how many of them. Okay, and then I sort them. Okay, let's run this, and then you will see what happened to this one. I got DF1 because not a very good name, but I don't know what to write. So once you do that, you look at DF1. Let's see what you get. So you will see I have beans is 1, 2, 3, right? Because this is a small company, 2 is middle company, and last big company. Right? And then I show you that the score of 1, 2, 3, 4, 5, 1, 2, 3, 4, right? How many of them? Right? Remember why I did that? This almost correspond to this graph. But this is relative. How many of them? 1, 2, 3. Well, this is relative, but we will calculate that, but just calculate the count. How many do, right? So just to remind you what we are doing here quickly is I divided it into 3 different groups. Right? That's what I do, group by. But of course, I filter first because I only need these 2 numbers. Okay, I filter, select the column, group them by these 2 groups, and count, right? Because count is size is count number of them. How many of them? So just look at how many of them are having a small firm. Actually, the score 1. How many small firms? 2 sorts. Okay. The next we do is to create another column called group count. Okay. And I do is by add them up. Sum is add them up. Add all of them together. Okay. And then I divide how many of them by the group total, get the percentage. So this one is to get the group, how many in the same group. Okay, because it's, let me run this one, and you see what I'm saying. Let me run this line. This is a rather tedious thing to explain, but let me show it. Run this line. Okay. And then let me show you this one. So this one would tell you how many sum is there, right? Because the first row is 72, 72. Why that? Because you're adding up all this. This add together is 72. Right? Because then I have 72 here. I divide them, I convert to how many them is in the same group. So that's why in the next slide, next line, I divide the count. Okay. How many of them? Right, you can divide that by the group count. Exactly. So what I do is I group by each group and I count them by sum. And then I divide them. Okay. And once I do this, is the percentage of the firm that is. Okay. Once I do that, you can look at it again. You can look at this number again. Right? Actually, this right gives you the percentage. Okay. Or if you want, I can show you the DF1, right? Which is like this, right? I have small firm, number one management score. This is a count within this group, and divide this into percentage. That's what I do. Of course, that you can check as many ways to do it. I follow this because this is how the way that the book recommends. Okay? You can do other way around. Okay, but this is the way that being done here. I still have time. I don't have time more, but next week we will go over the rest. Okay, is once we have relative frequency, we can call it categorical data, and once we do that, we can do the plotting. Okay, we can do a scatter plot like this, and we can see this kind of style. Okay, to see whether the big is it better the bigger firm they do better. Okay, so this is how you correlate, right? Because we didn't say okay, is it firm size with a good management score, or the other way around, right? We don't have the causality here, right? Can be firm is good management score, it's going to be big, right? Or because the firm is big, they have to hire good manager. I don't know which side. We don't know which one to cause which one, but we only able to see is big firm is more likely to have good management. But I don't know whether this cause this or the other way around. Okay? But hope that you know how to handle them. Okay. So as I said, I'm sorry. I supposed to let you go earlier, but I just 1 minute late. Sorry about that. Have a nice weekend. I hope you have a good afternoon. In the weekend. So I see you next week.